sanitize. Okay, we finished yesterday. We had a look at both of the two identities, am I correct? Okay, so we saw that sin over cos is equal to tan, and we also saw that sin squared plus cos squared is equal to 1. Did we get to that? Did we only draw this? We did number 1. So you know sin over cos is tan. Okay, great stuff. Next one, the second identity is sin squared plus cos squared. Do you see they have a square? They must have a square, okay? Now, if I substitute into sin from the graph, sin is opposite over hypotenuse, y over r, and cos is adjacent over hypotenuse, so it's x over r. Okay, now look at what happens. I raise the power, so I give each one of them the exponent 2. Now I've got similar denominators, so I just write it as one denominator. You remember I taught you like that in grade 8. Eh? So you write one denominator and then you add the numerators. Okay, so up to here, algebraically we can't do anything else. Okay, and here is the trick for the proof. I just want you to quickly look at this triangle again. You remember Pythagoras, ne? Yes. Pythagoras says that x squared plus y squared is r squared. R squared is y squared plus x squared. Okay. Now, do you see that the numerator is y squared plus x squared? And Pythagoras says that y squared plus x squared or x squared plus y squared is r squared. Do you understand? So that one I got because of adding those two. Now I'm saying when I look at that numerator, it looks like Pythagoras, and it is. So I take that out and I substitute back in the r squared. Is it making sense still? I'm going to say again. You know where I get this? You know where I get this? You know where I get this? Okay. So now I can't add y squared and x squared. But when you learn Pythagoras, you learn that the square of the right angled side plus the square of the right angled side will be the length of the hypotenuse squared. So this is a Pythagorean triangle. There's the right angled side, there's the right angled side, there's the hypotenuse. Writing this down would be x squared plus y squared is equal to r squared. Now this x squared plus y squared is exactly what I have there. I got that from there. So y squared plus x squared is r squared because of Pythagoras. Remember, you're going to do the application. This is just the proof. Okay? So I put the r squared back in there. So I've got r squared over r squared, which is 1. And because of this, whenever you see sin squared plus cos squared, the answer is 1. Sin squared 10 plus cos squared 10, 1. Sin square million plus cos square million, 1. But it must be squared. Okay. Because you see, if you didn't square that, you didn't square them there, you wouldn't end up having a Pythagorean situation. So you wouldn't be able to put in the r. Okay, so our second identity says sin squared plus cos squared is equal to 1. And now very important, we can get two extensions from this. So the first one we get is taking sin over to the other side. So just getting cos alone. I didn't do anything funny, I just took sin over. So I'm saying if those two added give me 1, then cos squared will be equal to 1 minus sin squared. Makes sense, eh? And sin squared will be 1 minus cos squared. So I just take the other one to the other side, to one side. And that's why it becomes negative. So you see the 1 is not negative. 1 must be positive, and the function squared must be negative. And you can just write down the next part. It doesn't come across a lot, but I just want to show you. Remember, trigonometry and algebra, they're very much alike. The calculations that you learn in algebra will be the calculations that you learn in trigonometry. For instance, factorization, quadratic trinomial, the difference of two squares, taking out something in common, so forth, so forth. Okay. Now, if you look at this thing, do you see that 1 is a perfect square? Minus sin squared, which is a perfect square. So this is the difference of two squares. So just take note that this can also be written as 1 minus sin theta, 1 plus sin theta. And the same for the cos 1. The difference of two squares, 1 minus cos theta, 1 plus cos theta. If you're done writing, you can write exercise 7, page 156. I'm going to do it with you. Are you done? Hurry, hurry, hurry. Okay, so when we do exercise 7, the instruction is to write it as a single trigonometric function. Okay, you can take a photo when we're done, all right? Because we're only waiting for one learner now. Write it as a single trigonometric function. Sin theta over cos theta. It's an easy one. Remember, we're just easing into it now. Who can help me? How can I write sin theta over cos theta as a single trigonometric function? Tan theta. There you wrote it as one. Okay, B is cos theta times tan theta. Is there anyone that has a plan? Okay, so what we use when we do these sums is we use our algebra rules. So for instance, this is like x times y. Okay, they're not the same. I can't do anything further. X times y is just xy. If you can't do anything algebraically, you're going to have to look for something trigonometric. So trigonometric would mean, is there an identity in there somewhere? Do you see maybe an identity? Something that can change into a different thing. Do you hear what she says? Tan theta is an identity. I can change it into sin over cos. And now that I've used the trigonometric knowledge, I can go back to algebraic knowledge, cancel them out, and I've got a single function. Do you understand, grade 11s? Okay. Sin theta over tan theta. Who has a plan? Tipisu? Okay, there's only one thing I can do, ne? You see, algebraically nothing. But trigonometric, I can change the tan to sin over cos. And then it looks like this. There's a fraction inside of a fraction. What do we do when there's a fraction inside of a fraction? Yes, Mona? We're going to write sin over 1. We change the multiply of the divide to multiply. And you swap the second one around. Do you understand that? And now I can once again use algebraic knowledge. And my sins will cancel out. I've got cos. Okay, 1 plus tan squared theta. So that's the same as 1 plus x squared. Do you agree I can't do anything with the sum? But can I do something trigonometric? What can I do? I can change tan squared to sin squared over cos squared. Okay, now the problem we've come across here in comparison with the previous two is the previous two was either multiplication or division, which made it one term. So we could cancel things out and what. Do you see there are two terms in here? And do you remember we are pretty restricted when it's two terms. There's not a lot that we can do. So we must try to make it one term. Okay? When I've got fractions, and I want to make it one term, and you must listen carefully now, you use your normal fraction rules. I'm going to give you those steps now again. I hope it will come back to you the way I said it to you in grade 8. Okay? If it's not fractions, we will use a different way of making it one term, and that will be Factorization. We did that with exponents as well. You remember? Okay. So, if you are in grade 8 now, and you will tell me that I'm not saying anything different. Step 1, make all the mixed fractions improper. Do you remember that? So I put that 1 over 1. Step 2, find the LCM denominator and make it one denominator. Make them the same. Okay? So, there's not something that they have in common, so we multiply them with each other. Ne? 1 times cos squared. So, it's just 1 times cos squared at the bottom. Then the next step says, what you do at the bottom, you do at the top. So, that denominator didn't have a cos squared, so you multiplied with cos squared, and you do it at the top as well. 1 times cos squared. That denominator did have cos squared, so you don't do anything there at the top. So you've got cos squared plus sin squared theta over cos squared theta. Did I do anything different? Nothing. Those are exactly the same words and steps that I taught you in grade 8. Make the mixed improper. Make the denominators the same with the LCM. What you do at the bottom, you do at the top. Only add and subtract the numerator. But algebraically, you can't do anything. You can't add cos squared and sin squared, because that would be like saying x squared plus y squared. But is there something trigonometric that I can do? Is there an identity? What is the identity? What? Komoto? It's 1. You cannot change that to tan, that part there. It's 2 term. Okay. Kumo, you understand what I mean? If it was multiplication, that sin can steal that cos. But because of the plus, can't do anything. Okay. One minus cos squared theta divide by sin squared theta minus 1. That's the same as 1 minus y squared over x squared minus 1. Okay, so although I hope you see the difference of 2 squares, even if you take it out, it's not going to help because the top is y and the bottom is x. Okay. Do you see an identity in there? Yes. What? Komoto? Komoto says 1 minus cos squared theta. Come on, is one of the identities. Look here. 1 minus cos squared is sin squared. You see? Okay? So 1 minus cos squared can become sin squared. Now look at the bottom. Is that an identity? The bottom? What is wrong with the bottom? The signs. If it was swapped around, then that would be an identity. Okay, but can I swap it around? How? I can just take out the negative. Okay, so Komoto said that's an identity. 1 minus cos squared, what is it equal to? Sin squared. And what is 1 minus sin squared? Cos squared. So I've got sin squared over negative cos squared. What is that? Negative tan squared. Do you get it? Okay, now we're going to do F. So you must keep remembering, you're doing algebra and you're using trigonometry. You're not cancelling one of them out. You try the one, there's nothing, you try the other. Okay. If you look at this, cos to the power of 4 plus, ding, 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 ding. Cos squared, sin squared. It's two terms, but it's not a fraction. Is there something algebraic that I can do? No, it's not a difference of two squares, because it's not perfect square there. Well, you can probably say that, but no. That, oh well, it's not a difference, it's an addition sum, so that cancels it out already. What types of factorization can we do? Common factor, is that what you said? Take out something that they have in common. Quadratic trinomial, difference of two squares. Okay, this is not a difference of two squares. This is not a quadratic trinomial because there aren't three of them. Is there something in these two that they have in common? What? Okay. So we can take out something in common. Okay. If I take out something in common, no, don't look at that one. If I take out something in common, here I'd be left with cos squared theta. Here I'd be left with sin squared theta. Do you all understand what I did there? Who says no? I take out the cos squared in common. There remains a cos squared, there remains a sin squared. Is there something I can do there? What? Komoto? Do you see the identity? Cos squared plus sin squared is 1. And then your answer is cos squared theta. Okay, now we're just going to take a look at the factorization. I'm saying it again, we made the notes when we did algebra. You can make the note again. The 3 ways of factorizing. Take out something in common, quadratic trinomial, and the difference of two squares. In grade 10, you also learned the grouping. We don't use the grouping. Okay. So that's how we make two terms 1 if it's not a fraction. If it's a fraction, you follow the fraction law. 2 sin theta cos theta minus cos theta. Who can tell me what type of factorization I can do here? Take out the, what can I take out? Cos theta. Do you see both terms has got the cos theta? So when I take out, I just showed you that's what it would look like algebraically. If you take out the cos theta, I would have 2 sin theta minus 1. So we're not solving anything now. We're just looking at the way the factorization looks in trigonometry. Okay. We're not doing a sum now. Example 2. Who can tell me what's this? Why? You see it, ne? If it was in algebra, or if you use the k method, it would be 2k minus 3, or 2k squared minus 3k minus 2. What? Oh, thank goodness I hate it as well. Don't worry, I'm not going on with it. I'm just showing you. It is k, the k is there as well. It would be 2x squared minus 3x minus 2, whatever. Okay. But I don't use the k method either. Nah. Remember, if you use the k method, it's fine. It's not changing any calculation that you are actually doing. The only thing is you're not writing cos theta, you are writing k. Okay, but the way that you do the sum doesn't change. Alright, so when I factorize this, please remember when we did equations in the first term, we did a lot of factorization. The completing of the square, the formula, you remember all of those? Okay, you are not going to need a formula to factorize trigonometric trinomials. Okay, we don't test the formula knowledge here. Okay, so it's easy peasy ones. Factors of 2 and factors of 2 that give you 3 when you subtract them. It's so easy. 2 times 2 is 4 and 1 times 1 is 1. No. So it's going to be 2 cos theta, and cos theta 2 has to multiply with 2. 1 has to multiply with 1. Now I just have to figure my signs out. The answer must be negative 3. So I don't want it to be 4 minus 1. I want it to be 1 minus 4. So that's why I put the negative in front of 2. So it will become 2 cos times negative 2 is negative 4 cos plus 1 cos. You understand? Example 3, I actually don't even want to do with you. It doesn't come, we don't see it in the questions a lot. So you can just look here, you don't have to copy it. But these are the sums that you do in grade 9. So it's this one squared plus xy plus y squared. So the only difference is when you have your brackets, instead of having a function and a number, and a function and a number, you have a function and a function and a function and a function. So if there was a 2 in front of that one, then you would just put your 2 and your 1 in there. You just write the cos or the sin with it. Okay. But we don't come across it a lot. Then example 4, I hope you can all tell me what that is. The difference of 2 squares. So if I were to factorize it, it's 1 minus cos and 1 plus cos. Okay, everyone done. Mbulelo, your friends are looking for their phone. They want to use your phone. If you want to go and help them, you can run out, but I'm going on here. Go. Write, this is example 5. Write as one trig function, or let's say expression. Is there someone who sees a plan? What? It's the difference of two squares. So I can take the step back. What will it look like if I multiply these two fractions? Oh, you are very clever, ne? 1 minus sin squared theta. But the instruction is to write it as a single, one trigonometric expression or function. Can you change that thing to a single thing? What? That you got from the identity. Do you see how quickly you're picking up on it, ne? In the beginning, we struggled to see it. Okay, B. Cos squared theta minus 1. Is that an identity? Is it almost an identity? What must I do? And now? What's the answer? Negative sin squared theta. That thing is very ugly, but it's tan squared theta minus tan squared theta sin squared theta. I told the Afrikaans class it looks like this. It's like y squared minus y squared times x squared. That's the same. Do you want to try it yourself? 2 minutes. 2 minutes. I'll only give you 2 minutes. Remember, try something algebraic. Try something trigonometric. I would start with algebraic because of the two terms. you done? Okay, time's up. So there are two things that you could have started with. One is more correct and the other is not wrong but less correct. Okay. So either you could have changed tan and tan both to sin over cos. Okay. But I think that would kind of expand this question instead of making it smaller. Okay? So what I would do here is I would rather take out the tan in common so that I have fewer functions. Then my problem is becoming smaller. Then it looks like this, tan squared and 1 minus sin squared. Did you do that? Yes. Okay. Now I can change tan and I can change 1 minus sin. Do you agree? Yes. What can I change tan into? Sin over cos, and 1 minus sin squared I can change into cos squared. Now the reason I'm putting it over 1 is just for myself to cancel out any confusion about whether this is the denominator or the numerator. Because if it's standing alone, I'm unsure. Okay, so I already put it on the denominator to indicate to myself. And now, do you see I can do something algebraically again? And then I've got sin squared theta. Okay, I will do D with you. Do you remember how we square a bracket? How? Okay, good. First one times itself, first times second times 2, second times itself. You remember that? Yes. Would you be able to do that? Yes, and then it would look like this. Cos squared theta plus 2 sin theta cos theta plus sin squared theta. Algebra, ne? Nothing new. Do you see something? Anything? Algebraically, we can't do anything. Do you agree? It's like x squared plus 2xy plus y squared. Do you see something? If we're not finding anything algebraic, we know we need to look for something trigonometric. Do you see something? Yes. Don't care about sees it. Is there someone else who sees it? Leakwe, do you see it? This is a trinomial. Is that what you said? No. But remember, it's a trinomial because I made it a trinomial. So if I were to factorize it, I just go back to that. Okay. So algebraic, I can do this and I can go back to that. Nothing else. Nonkeba, wat sien jy? They are just separated. They are still there. Cos squared theta plus sin squared theta, what is it? And then there's nothing more that you can do. Okay, grade 11s, Mbulelo, hier's jou chommies, gaan. I want you to write NB, NB. Okay, the type of sums that we are going to practice now is we are going to say, prove that. Prove that 1 over cos squared theta minus 1 is equal to tan squared theta. Alright, we did these type of sums in algebra as well. So what happens is, this is not an equation. Okay. Do you remember the difference between an equation and an expression? With an equation, you can move around underneath the rainbow. No, the equal to sign. With an expression, you can only work on one side. Okay. You cannot solve the value. You will not find out what is theta. You will only simplify it. Okay. So what they're doing here is they're giving you the left side and they're giving you the answer to this thing once it has been simplified. And they're asking you to prove that this is equal to tan squared theta. Okay. So you're not going to write that equal to. You see there's nothing there. That was the last time I wrote it. Now when I look at the left side, please help me. That tan, this is the problem with the identities. There are many things that can happen. Many things. But look at the right hand side. The right hand side is one term, where the left hand side is two terms. So that would be a good starting point. Now remember guys, I told you we will come across two things. Either factorization to make it one or fraction rules. Is this a fraction or factorization? Fraction. Can you all see it's a fraction? It doesn't hide. It's got a line. Then you know it's a fraction. Okay. So what is step one? Make the mixed fractions improper. So I put that 1 over 1. Okay? Step 2 is you make it one denominator. So cos squared theta times 1 is just cos squared theta. Now I just want to show you what you're actually doing is you're multiplying this one with cos squared theta, and then you're also doing it at the top. Because then we're multiplying with 1, so we're not changing the value. Right? So I've got cos squared theta at the bottom. This one didn't need to get anything because the denominator is already fine. But this negative 1 I had to multiply with cos squared theta. Have I done anything new? No, I just applied my grade 8 fraction steps or rules. That's all I did. Now, algebraically, I wouldn't be able to do something now because it's 2 terms. Okay? Do you maybe see something trigonometric? Yes. What? It is? And what do you see now? It is tan. And then you just say left side equal to right side. And you're done. Was it hard? No. Next up, prove that tan theta plus cos theta over 1 plus sin theta is equal to 1 over cos theta. Grade 11s, do you see fractions or factorization? Fractions, no. Okay, with the previous one, we made it 1 over 1. If it was, for instance, cos, we would make it cos over 1 or sin over 1. But do you agree that we can make tan a fraction without just putting it over 1? Do you all see that? Yes. Then you would rather choose that. Because you have cos and sin functions. So obviously it would be better to get this one to be cos and sin. Okay. So what I would do is I change tan to sin over cos. Okay, so you are still with me, we are still on fractions. Okay, step 2 is to find the common denominator and make it one denominator. So I can't find something common, I just write them together, multiplying them. It will look like this. Cos theta, bracket 1 plus sin theta. Do you understand what I did? Let me just close it there, because I just first want you to focus on the denominator. You all understand? Okay? Then I'm going to say, what does this cos theta need to look like this one that I've created? It needs 1 plus sin theta, so I multiply that sin theta with 1 plus sin theta. What does this 1 plus sin theta, please let me finish this. What does this 1 plus sin theta need to look like this denominator? So I multiply that one with cos theta. It's only 3 more steps, then we're done. Okay. Now just listen to me for 1 minute. You can multiply this cos theta in at the bottom. Okay, you all know how. It's a distributive law. Sometimes it will be necessary for you to multiply it in, and sometimes you shouldn't do that. But at this stage, I wouldn't do it. Let me just tell you why. Because we don't know what's happening at the numerator at this stage. Let's just calculate it first. And then see, do I need it like this? Or do I need it multiplied in? To multiply it in is easy. You can do it at any stage. Do you understand what I mean? Okay, so here I'm going to say sin times 1 and sin times sin. Then it will be sin theta plus sin squared theta. And here I have cos theta times cos theta. It will be cos squared theta. Do you see something? What do you see? Sin squared plus cos squared is 1. So at the top I have sin theta plus 1. And at the bottom I have 1 plus sin theta. And now I can go back to algebra, cancel them out, and I've got 1 over cos. And that's exactly what I had to find. So the left side is equal to the right side. Do you understand, grade 11s? Are you sure? You're going to try this for me for tomorrow? In the textbook, they say it's exercise 11. We know the last one we did was exercise 7. But it should be 8, but it says 11 in the textbook. On page 157, A, B, C, and E. There it is on the board. Okay. Remember, don't write the right-hand side equal to with the right-hand side. Just the left-hand side. And you simplify it. You can write times 1 if you want to. There it is being subtracted. You understand the difference. So you can, if you want to, definitely write times 1 or 1 in brackets. It just doesn't make a difference.